Hello pre-calc. So making the video 1. So this is just reviewing the properties of logs and what is a logarithm. So remember that a logarithm, it is the inverse, and we've already talked about inverses, of an exponential, and it's so that we can solve for unknown exponents. And so since it is the inverse of an exponential, I'm just going to quickly go over what a graph would look like. We know that exponentials can look like this. So this would be y equals a times b to the x. That means the log, since it's going to be the inverse, is going to have the y-axis as its asymptote, and it would grow very slowly, where the exponential grows very quickly. Y equals log base b of x. All right, and the line y equals x would run right down the middle. All right, so that's what it looks like as a graph. Let's look at what we have going on here. So we have log base b of x equals y. That would be your logarithm. The corresponding exponential, remember we did that little loop-de-loop thing where you pick up the base, it's all about the base, b to the y equals x. And then you have different bases for your log. You have log base 10, which is called your common log, and again 10 is optional whether to write it because it's understood to be the default. So now your base is 10 to the y equals x. That is called the common log. Things like earthquakes are base 10, fun stuff. And then you have your natural log, which is base e. So we write it as natural log ln. It's actually logarithmic naturel for anyone who speaks French. Sorry, pardon my blustering the language. And since it's a base e, that becomes e to the y equals x. So that is your natural log. We don't write it usually this way, but just to emphasize, it's log base e. All right? So there's sort of your definition of a logarithm in terms of an exponential. And then you have being able to convert from one to the other, just getting comfortable. And I'm not going to always do the little loop-de-loop thing because, you know, you guys are big kids now. We don't need to show that. But if I was going to rewrite this, again, you have to write as a log. You have to write the word log. Our base is 2. I'll do it once, okay? We always start at the base. It's all about the base. And we pick up the 8 like this. So log base 2 of 8 equals 3. Notice that the exponent's on the other side because logs solve for an unknown exponent. So this one would be log, the base is 36 of 6 equals 1/2. Notice that your argument 6 is smaller than your base because you took a square root of that 36. Then we have log, again now base 10, which you don't have to write, of 1 over 100 equals -2. Notice that when the answer is negative, that means you are raising something to a negative power, which gives you that fraction. And then going in the opposite direction, so again, it's all about the base. I'm only going to do it once, but we always start at the base. And now we drop the log. So this is saying 3 to the 4th is 81. And what the heck did I just hit? Sorry. And then we have 27, that's our base, raised to the 1/3, that's the exponent, equals 3. The cube root of 27 is 3. And lastly, we have 2 raised to the -4 equals 1/16. All right, so hopefully that brings back fond memories. I gotta tell you, I love logs, so, you know, get ready. All right, product property. Okay, expanding. So the product property says that we are going to take any product here inside the parentheses, and I can expand it, same base as log of A plus log of C. So in other words, multiplication and addition go together just like they do with exponents. When you're multiplying bases, you add the exponents. So log base 2 can be expanded as, I'm going to rewrite 18 as 2 times 9. I can expand this to log base 2 plus log base 9. And hopefully you remember that log base 2 has to equal 1, right? Because 2 to the 1 is 2, so this simplifies to 1 plus log base 2 of 9. And I would leave my answer like that if I don't have a calculator. I keep hitting the wrong thing, sorry. All right, and now you can also go the other way, and condensing is really what we care about when we're solving equations. Expanding is what you care about in calculus so that you can do things like take derivatives and integrals easier. But for us, condensing is really the more important property because it allows you to solve. You need to condense it into one log. So it's log with, notice they both have the same base. We aren't going to be evil and not give you the same base. And since it's addition between, I multiply the arguments. So 4 times 3, which we can now write as log base 7 of 12. And we're done. All right, quotient property. Well, that is when you are dividing. So A divided by C, and division goes with subtraction. So A minus log C. And so if I had log base 2 of 2/9, this becomes log base 2 of 2. So it's top to bottom, numerator, then minus log base 2 of 9. And once again, log base 2 of 2 can simplify to 1. And we have this. Now there are other fancy things I could do with that, but I'm not going to right now. Then we want to condense, because again, that's really what we care about when we're solving. So we condense it into one log. That's the whole idea of condensing. It should be just one log. They have the same base. And then we take the arguments and we divide the arguments. So this becomes log base 2 of 7. All right? So you have your product property, you have your quotient property, and last one, and one of the most used, which we actually did just use, is the power property. So A raised to the C becomes, that C can travel in front, so C log A. And you saw how we did that, so we can solve for that unknown exponent. So if I am expanding, this 2 can travel in front. 2 times log base 3, 5. And there we go. And then condensing, it can also, so it travels in both directions. Log base 7 of 16 raised to the 1/2, which is taking the square root of 16, which is 4. All right, so those are your basic properties that you really want to be comfortable with because we're going to use them when we are solving. What I have here is a little bit of fun. Derivation of using the product property for logs to show why log base 3 to the 4 equals 4 log 3. So let's see what this means. All right, I'm going to start with log base 3 raised to the 4th power. It's like, okay, well, what does that mean? That means log of 3 times 3 times 3 times 3, right? That's 3 to the 4th, another way of writing it. But now we have this property that says multiplication becomes addition. So this becomes log 3 plus log 3 plus log 3. Hopefully you see where I'm going with this. How many logs 3 do I have? I have 4 of them. And voila, that is why this is equivalent to this. All right? I think sometimes it's nice to see where things came from. It's not just pulling little equations out of our hat. All right, now we want to be able to expand this. Okay, so this requires just taking it one step at a time. So the first thing I'm going to do is I'm going to bring that 4 down in front, and I'll do it step by step. Why did I have to put a base in here? So I have a base, I have x, my goodness, I can barely see this, it's so tiny, w times z squared. Oh, we have 2 things in the denominator, which is good. Okay, so I took care of that 4. Now what I'm going to do is I'm going to use my quotient property. So this 4 is going to sit out in front for a second. And we have log base 4 of the numerator minus log base 4 of the denominator. Okay, hope you're still with me. And then we can expand each of these using our product property. So that 4 is still going to sit out in front. Sorry, bud, you're just going to have to wait. So this is going to become x, and then plus, I'm going to do 2 things at once here. That 3 is going to come out in front, log base 4y. All right, so I'm done with that fraction. Minus, now realize this negative is going to have to distribute. That is the key here. So when I break this up and do w plus, that initial minus here will have to distribute. So we have log base 4w, but instead of plus, it's going to end up being a minus just because that negative had to distribute. Oh, I'm going to bring the 2 in front, z. And then in the end, I distribute my 4 to everybody. Ooh, that's a fun problem. Okay, plus this becomes 12 log base 4y. Now I have a little shortcut to help, oops, got my 4 here. Can't talk and write at the same time. There we go, 8 log base 4, sorry, forgot the 4 there, z. Whew, that one was long. All right, basically anyone that's in the numerator is getting added together, each term. When you have more than one term in your denominator, that negative is always going to distribute. So basically the easy way to remember is anything in the denominator is going to have a negative in front of it if you have more than one term, okay? All right, last one, we want to condense. So the first thing we do when we condense is we have to move any exponents up front. We only have 1, all right. So I've got log base 5, 2 cubed, which is log base 5, 8, because that's 2 cubed. All right, I'll just, So when you get better with these, you'll also notice anyone with a negative is basically going to go downstairs. Anyone with a positive is going to go upstairs. So these 2, let's start off one at a time. Those will condense into log base 5, 8 times 3, which is 24. What I'm going to do here to kind of emphasize what I was saying is I'm going to factor a negative out of these 2. So this becomes 4 plus log base 5, 2. So you can see, I know there's faster ways to do this, but I'm trying to show the steps. So here this becomes minus log base 5, 4 times 2 is 8. Now, whoops, I didn't need that last little parenthesis, but that's fine. Okay, then the final touch is we condense into 1 log. So when you're condensing, there should only be 1 log in your answer. Otherwise, it doesn't make sense. The most common answer I get is log base 5, 24 divided by log base 5, 8. It's like, no, it's the arguments that get divided. So this gets divided by that. And since that is something we can simplify, look at that. What a sweet little answer that was, coming from that big long thing. All right, that is your review.